So it's recording. Yes, thank you very much. And open chat. Chat. Okay, good. Okay, so don't forget to sign in the chat. Now, a couple of notes on that. When you sign in the chat, use your name that's registered, that you register with. Because some people write their name different, or they change the name, or they put in different names. If it's hyphenated, they use one but not the other. And so then it makes it difficult for me to see who's here. You know, once we get into the classroom, then we can make any changes. If you want to, if you got a hyphenated name, you want to use the first one instead of the second one, whatever it might be, or you want to use something else, you want to use a nickname, I don't care. Then we can make those changes when we can talk face to face in the classroom. So for right now, for this first 3 weeks, please just sign in with your the way it's registered, because that's the list I have. And that makes it easiest for me to see who's here and who's not. Okay, let's see what else. I had another announcement. Yes. Another announcement on the homework. So when you do your homework, so I'm posting homework 2 ways. So one, I give it to you when I send the video. So last night I sent a was it last night? No, not last night, the night before last. So on Monday night, I sent a recording and I sent a Word file of the homework assignment. Okay. And then the next morning I put it on Canvas. So it's in both places, but we're not turning in our homework on Canvas. So we're going to do our homework hard copy, and we're going to do it. Just turn your homework in when we meet back in the classroom. So that'll be on February 23rd when we meet back in the classroom. And also we have a test that day. So I know it's a lot of stuff going on. I might even postpone the test till the next week. I'm not sure. I haven't made that decision yet. It's just the way they've goofed up this semester makes it very difficult to keep track of everything. There's a lot of moving parts, and I'm not exactly sure how they all fit together. But all of our homework we're going to do on hard copy, just paper and pencil, turn it in when we get back in the classroom. The last thing here is one of the things that the Mesa College stand department, they aren't actually a department, it's called the Mesa College stand, but that's a separate room. I don't know if you've ever been there before, but they have food, they have other things, services that people might need, supplies sometimes that they can give out. They have clothes. If you're going to do an interview and you don't have a good suit or something like that, then they might have some clothes that they can fit you into for purposes of the interview. But one of the other things they do is they do a farmer's market. So we do this a couple of times throughout the semester, but there's going to be one this on Monday, February 7th. There's going to be a farmer's market. It's not 7th. Oh, it's only the 2nd. That's right, the 2nd. So there's going to be one on the 7th. And typically for the during COVID, they've done this for the last 3 semesters, is they do it in the parking structure, and it's a mobile farmer's market. So you come through in your car, and they give every car or truck about 30 to 40 pounds of food. Most of it is fresh produce, and it's good stuff. You know, it's not the stuff out behind Ralph's in the dumpster or something like that. This is regular good produce, and that's most of it is produce. Let's see, fruits and vegetables, things like that. But they also look for volunteers to help out. So they are looking for volunteers. So if that's something that you think you might want to help out with, just let me know, and I can hook you up with a point of contact. The thing is, if you are a volunteer, you get first pick on everything, and that's really nice. And it'll be run on Monday, February 7th from 12 noon to 2:30. So from 12 to 2:30, that's when it's run, and then it's over. So it just starts then, ends then, boom, like that, and it goes real quick. And usually a lot of people show up, and all of the produce goes. Let's see, but if you're one of the volunteers, then you get first pick. But if you're interested in that, let me know. Okay. let's see, what else? Okay, so another thing, you can see I got stuff written on the board behind me. So this is the way I run all of my classes. So when you come into the class, there'll be stuff on the board, or I'm writing stuff on the board because I'm trying to catch up. And what it is, it's a review of the highlights of what we covered last time. Now, my test, when I make my test, it's made into a matching section. So the first 10 questions are all matching. Match up stuff in this column with stuff in this column. And the matching items I take from what I write on the board back here. And this is highlights right out of the textbook. And then there'll be a number of problems and then a couple of extra credit problems at the very end. And I'll go through more on that before we take the test. So anyway, so I have a review behind us. Any other quick administrative remarks on the syllabus, what we're covering, the book, anything like that? No. Okay. Everybody's quiet. I'm glad to see that some people have their cameras on. Thank you very much. I appreciate that. Okay. So let's take a look at what we got behind us right here. So we started off in section 8.1 talking about systems of equations in two variables. All right. So a system is two equations in two variables or three equations in three variables. That's the two types of systems that we're going to talk about. Okay. So the objective of this system, if you get a system, the objective is to find the variable values that satisfy the system. And that's what we're going to be looking at in the next several sections here of chapter 8. So methods to solve. So we have various methods where we can solve this system. We can do it graphically. That's what we looked at in 8.1. And we can do it by what's called substitution and by elimination. And we'll look at those in 8.2. Translating. Translating is changing keywords to algebra and equations. So one of the ways to make a system, I got to make these equations first, if I got a word problem, is to be able to translate words that mean mathematical and algebraic operations into sentences. If I can do that, then I can make the sentence into an equation. Okay. So word problem, the general word problem method or strategy over here is one, it's a word problem. So you got to read it and hopefully then you have to understand it. Maybe you have to read it more than once in order to understand it. Then you got to make variables. So somewhere in the problem, they ask you to find something. That's what you make as your variables. Then 3, once you make the variables, then 3, you make the equations. That's the hardest step, making the equations. And we'll talk more about that as we go along. Then 4, once you make the equation, you solve the system. That's usually the easiest step, is solving the system. Step 4 right there. And then 5, you check the solution. And then 6, you can write down your answer with appropriate units. So to make the equations, so far we looked at 2 general methods to make the equations. One, we can use keywords. If I can translate keywords into an English sentence where I got a subject, verb, and object, then I can translate that directly into an equation. So usually the English sentence will translate 1 for 1, subject, verb, object, left side equation, equal sign, right side, into an equation. So on there, the keywords, you can review the keywords in section 1.1 in the textbook. And with this note, the verb is usually the equal sign. And a lot of times it's the verb of being. So is, was, has, have, something of that nature. That's typically the equal sign word. But we'll see other verb words that are the equal sign also as we go along. Okay. That's side 1. Oh man, here's side 2. We covered a lot of stuff last time. Let me scooch back over to this side. All right. So another way to make the equation is called make a table. Okay. And the table is based on the problem relationship. In example 2, we looked at the relationship of buying things. That's called the cost relationship. And what that is, that the amount of things that you buy times the price of each item is equal to the cost that you pay at the cash register. So here's the example 2. So down the left-hand side, I have my particular items. In example 2, where they were making necklaces with 2 different types of stones, I guess. Well, stones are two different types of things. There were silver stones, I guess, silver pieces, and then there were gemstones. Whoops, that's the wrong kind of gem. That's the gem that you work out in. So J-E should be G-E-M, gemstones. Anyway, so those are my two items. And then I have a total down here at the bottom. And then out this way here to the right is based on the problem relationship. So in this one here, you always put the relationship in the table backwards so that the equal sign is over on the far right-hand side here. Okay, so here I got the amount times the price equals the cost. Okay, and down here, each row here is a separate equation. There we go. Each row is a separate equation. So here are my variables. So I'm asked to find the amount of each of these items that I use, and I bought 30 of, I bought 80 of them. So here S is the silver, G is the gems, and 80 is the total. And then the price was 40 cents for the silver, 65 cents for the gems. And then coming across right here, I got 40S, 65, or 40S. This should be 65G. Error right there. 65G is equal to $39. So the total amount that I bought was $39 worth. Now over here, I'm working in cents. So 40 cents, 65 cents, $39 is 3,900 cents. So this is a common mistake that usually people make in word problems that involve prices of things. You got to either work in pennies or work in dollars, and you got to pick one of the two and keep that consistent throughout your problem. So here we decided to work in pennies. So here, 40 pennies for the silver, 65 pennies for the gemstones, and then 3,900 pennies for $39, the price that we paid for 80 items. Okay, now I got my two equations. So the first equation is right here, S plus G equals 80. The silver plus the gems is equal to the total. And over here, the cost of the silver plus the cost of the gem is equal to the total cost. So those are my two equations, equation one, equation two. So equation, then I can write down my system. So S plus G equals 80, 40S plus 65G is equal to 3,900. And I put a line under it. So these notes, one, number the equations. That's important. Get into the habit of number the equations. This is going to be really important, especially when we come to solving systems with matrices and determinants, which we'll do later on. And then two, put a line under the original system. So that's my original system. That's my starting point. Okay, if I check if I check my solution, I always have to go back to the original system to check it. Okay, check a solution. So to check a solution means one, substitute using parentheses, and two, do the math. So if I I'll tell you this on test one, is x equals 1, y equals 3. Is that a solution for this system? So that doesn't mean solve the system. It means check the solution. So I have to substitute the 1 and the 3 into my system using parentheses and then do the math. And if the left side equals the right side, then it's a solution. That's how we check it. Okay, going up to the top of the next column. So solving a system graphically. So we looked at our first methods of solving a system, and that's doing it by graphing the system. So here, you graph the equations and the intersection wherever typically we're looking at linear systems. That means they're straight lines. So wherever the straight lines cross, that is the solution. That intersection where they cross, that's the solution of that system. So methods to graph. So you can graph using intercepts. So if it's real simple, especially if the coefficients of the x and y terms is +1, plus or minus 1 even, then I can use intercepts. And that's called the hand method. That's where I put my hand over it like that. And that means it's that one value is 0. And then I can just find the other value. And that's where it crosses the x or y axes. And the second method is using slope intercept form. Okay, so we'll do more examples of that as we go along. We have three basic types of systems. So I got a consistent system, I got an inconsistent system, and I got a dependent system. So a consistent system means there are two lines intersect and there's one XY solution. Okay. An inconsistent system. So in is a prefix means not. It's not a consistent system. So those are parallel lines. They don't intersect. So there's no solution. Okay. And the last one is a dependent system. So a dependent system is the same line. So when I graph it, I'll have the same line. Then I got infinite solutions. The two ways I can recognize these, I can recognize if they're parallel, if the slope, if I put it in slope intercept form and the slopes are the same, that means there's parallel lines and there's no solution. For the dependent system, all of the terms, if I put it in y equals mx plus b slope intercept form, then the slope and b, the y-axis intercept, has to be the same. If they are, that means they're the same line. So there's infinite solutions in that case. So if they have the same slope, they're going to either be no solution or infinite solutions. Okay, and that takes us through the highlights of what we covered last time. We're going to start off this time in section 8.2. But first, any questions? I think someone had a question on the homework problem.
Yes, yeah, 23, number 23 and 25 is what I had a question.
Okay, so let's take a look at these. Let's see, where's my textbook? Oh, it's over here. Boom. Okay. There we go. Okay. Over to here. Hang on. This goes back over here. I have a limited amount of space, very limited. So usually I'm tripping over things here. Okay. So here we go, 8.123, right? Okay, let's take a look at that. All right. So it says solve these systems graphically. Okay, good. Oh, 23 is a good one. Okay. And so is 25. Those are two good ones. And they're so simple that people can't see the solution and they think there's some sort of trick system or something. But I'll show you what the trick is. Okay, so let's take a look at those. Any questions on the review portion right here? Okay, good. Back over to this side. Okay. Clean this up. Incidentally, did anybody take a look at the video that I sent back? Was it clear? Did it help out at all?
It did help, yes.
Okay, good. Okay, there we go. Okay, so this is 8.123. Okay, so one of the things you want to do, the author doesn't do this, is whenever you write down your system, number the equations and put a line under the original system. So here, 23 is x is equal to y. Oh, wait a minute, hang on. We have a pen emergency. I ran out of ink. No problem. Hang on just a minute. We got to go over here. Here we go. Get pen number 2. Okay. There we go. Okay, so we want to get in the habit of number the equation. So our first one here for 23 is x is equal to y minus 1. And 2 is 2x is equal to 3y. And there's our original system. Okay, so the first thing I'm going to do is I'm going to put them in slope-intercept form. I'm going to do that because I want to show you something in slope-intercept form. I could graph them directly using the hand method right from there, but I don't want to do that. So I want to put them in that form. So number 1 here becomes y is equal to minus x minus 1. And number 2 becomes, let's see, 3y is equal to 2x, or y is equal to 2/3 x. Okay, so there I put number 1 and number 2 in slope-intercept form. So the two things I can see from this, one is notice their slope is in opposite directions. So this has a negative slope. So what does that mean? So a negative slope in the coordinate system goes like this. Okay, this has a positive slope. So a positive slope in the coordinate system, rats.
Yeah, I got a question. How come you put x equals y minus 1?
Stand by. A positive slope goes like this. So what does that mean? That means that these are definitely going to intersect somewhere. So what was your question?
The question was, how come you put x equals y minus 1 on 23? I thought it was a equals 1 plus b.
Because that's what it says in here. X equals y minus 1. That's equation number
The
1.
same. I thought the same.
Isn't it supposed to be y equals 1 or x plus 1?
Wait, what?
No, if I solve, oh, it is plus, my bad. Okay, so if I solve this, yeah, it's that's plus and plus. My bad. You're correct. Thank you very much for paying attention. Okay, so that changes the slope to the other direction. But still, I think that these two will intersect because they have different slopes. Okay, so notice another thing over here, right here. This is plus 0. Notice I wrote that in dash lines because you can't see it. So here b is equal to 0. Yeah. Okay. So two things. So one thing, this one is m is equal to 1. So 1 over 1, I always write it a fraction, and b is equal to 1. Down here, m is equal to 2/3, and b is equal to 0. Okay, see b is 0 on that one right there. Anytime b is 0, that means it goes through the origin. It goes through the center. Okay, so let's graph these. I think I can graph them right here. Let's see, where are they going to intersect? Yeah, okay, I should be able to graph them right here. Let's see. And then I can put the other one up over here. So here's my graph paper. Okay, there, I label my graph. Okay. Now, number 2 right here might be the easiest one to graph because it goes through the origin because B is 0. So that means it's going to have a point right here, like this. And then I'm going to go out in the X direction. Remember, X is the bottom number right here. So Y is the top number, X is the bottom number. So I go out 3, 1, 2, 3, and up 2, 1, 2. And I put a dot right there. And I can go in the opposite direction too. 1, 2, 3, 1, 2, and put a dot right there. So this is line number 1, goes like this. That's line number 2. Okay. Now let's graph number 1 right here. So number 1 has a y-axis intercept of +1 right here. And it is a slope of 1. Okay, so 1 over 1. So that means it goes out the same amount of X as it does Y. Okay, so I can make it real easy. I'll go out to 3. So 1, 2, 3, 1, 2, 3. And there's a dot right here. And then 1, 2, 3, 1, 2, 3. There's a dot right here. Oh, right in the same place. Okay, so when I connect these dots up, it goes like this. So there's the solution right here where they cross. So here the solution is X equals -3, Y is equal to -2. Okay. So the tricky one on this is this equation right here. Anytime B is 0, that means it goes through the origin. Okay. And on this one here, if it is a slope, make it a fraction, 1 over 1. So then I can make this 3 over 3, for example. That makes it easier to put in the second point. But anytime you graph a straight line, you want to put in at least 3 points. 3 points. That way, if you make an error on one of the points, the third point is a checkpoint. So notice on each case, I put in 3 points. Okay, does that make sense on that one? Let's look at 25. So here we're going to solve the system right here. Y is equal to 1. Y is equal to -1. And 2 is X is equal to 3. Okay. Now these two equations represent are 2 special cases of a horizontal and a vertical line. Okay, so this first one up here, number 1, is a horizontal line like this. Number 2 is a vertical line like this. Okay. So the equations are already solved for. All I have to do is graph them. So here, let me make our coordinate system. Okay. So equation number 1 here is a horizontal line right here. I just put a dot right there at y equals -1. And then I draw my curve out like that. This is equation 1. And like that. So that's equation 1. And then equation 2, x equals 3. So I put a dot there at x equals 3. And then I draw the vertical line like this. This will be equation 2. And then down like this. And so here's my solution right here. At the point 3, -1. So notice, just by looking at that, I can tell you what the solution is. I don't have to graph it. But here, I might ask you to graph one like this on the test, because it's kind of a sneaky one. And people they'll get thrown because I can't put it in slope-intercept form. What's going on? Okay. Or if I use the hand method, it's even more confusing. Okay, good. Good questions. All right. So tonight, we're going to start with section 8.2. So in 8.2, we're going to look at 2 other methods that I had on the review there for solving systems of equations. And that's by substitution and by elimination. So many times, if I try and solve it graphically, the intersection is not at the intersection of the graph lines, but it's between the graph lines. So that means I can't get a clear-cut answer on what the solution is. I have to estimate it. I have to sort of guess about how far between the lines it is. But if I use one of these other methods, then I will get an exact solution. Okay, hang on just a minute. I got to get my notes out right here. There we go. In section 8.2. That's what we want. Okay, good. Yeah, let me flip the board over. Okay, good. Okay. Okay, and the first objective here. So the objectives in section 8.2 are 2. So objective A is to solve by the substitution method, and objective B is to solve by the elimination method. So we're looking at objective A right here. Solving a system by substitution. Okay. Now the author has this method written down somewhere. Hang on. Let's see what page it's on. I cannot remember. Oh, it's over on page 535. He outlines both of them over there. But what I'll do is give you a little methodology, and I'll try and simplify it a little bit. Okay, so here we're going to do 1 we're going to solve for one variable in terms of the other. So what does that mean? So that means I'll look at whatever the easiest variable is to solve. If I solve for X, then I'll solve for X in terms of Y. If I solve for Y, then I'll solve for Y in terms of X. So I'll pick whatever one. It doesn't make any difference which one you pick. Pick whatever is the easiest one to solve for. Okay. And then 2, you substitute into the other equation. Okay. And what that's going to give you, once you do that substitution, what you get is one equation in one variable. So then you can solve for that one variable. Okay, so I can solve for that one variable. It's not very good right there. Okay, good. All right. Then 4, once I get that one variable, I can go back into this up here where I solve for one variable in terms of the other. I can go back to that equation number 1 and solve for the other variable. So use first equation. To solve for other variable. Okay. Then 5, the last one is always the same, check. Check solution. And I always have to go back to the original system to check the solution. So there's my method right there in a nutshell for solving by substitution. Okay, we're going to look at some examples right here. Okay, some notes on this. A couple of notes at the bottom here. Notes. And the first note is to, let's see. This is good when one of the variables has a coefficient of plus or minus 1. Especially plus 1. So when one of the variables has a coefficient of plus 1. So coefficient is the number that's in front of the variable term. That's what that is. Okay. 2. Use parentheses to substitute. So anytime I substitute, I want to put it in parentheses. And then 3, check in original system. Okay, so let's review what we put in. So the method in then is to 1, solve for one variable in terms of the other one. So pick whatever easiest one is to solve for. 2, substitute then into the other equation. And that'll give me one equation and one variable. So I can solve that equation for one of the variables. And then I go and use the first equation that I solved for up here in step 1 to solve for the other variable. And then I check my solution with these notes at the bottom. It's good, especially when one of the variables has a coefficient of +1. That makes it easy to solve for. And 2, use parentheses to substitute. Then finally 3, check in the original system only. So let's look at an example right here. So this is example 1. Let me make sure it's the same example as in the book right here. Yes, it's example 1. Okay. So in example 1, I have this system, x plus y is equal to 4. And 2, I have, what's 2? X is equal to y plus 1. Okay. Now this one actually lends itself to solving by substitution. Why? Because the x variable is already solved for. So step 1 is already accomplished just by the way that the system was stated. So I can do the substitution directly. So I'll use equation 1 right here. Whoops, Using equation 1, I just substitute directly. So I'll have y plus 1 plus y is equal to 4. And now I got one equation and one variable. So I'll solve that for y. So getting rid of the parentheses, y plus 1 plus y is equal to 4. So I'll subtract 1 from both sides. So I get 2y is equal to 4 minus 1, and y is equal to 3 halves. Okay, so here I get a fraction answer, y equals 3 halves. Okay, that's 1 1/2. So you can see if I tried to solve this graphically, that would be easy to put up graphically, but then my solution is going to exist between the graph lines. So I'm going to have to estimate what the solution is. So now once I get this, I go back to equation number 2 here, and I can solve for x. So x is equal to 3 halves plus 1, which is 2 halves. Whoops. 2 halves. So x is equal to 5 halves. So then here my solution is 2 1/2 and 1 1/2. Now, the easiest thing when you get fraction answers is don't right away make them into decimals. Keep them as fractions, but write them as mixed numbers. So that's the easiest way to graph a fraction, is if it's a mixed number. So here that's 2 1/2. So I can see exactly where it is on the x-axis, and y is 1 1/2. I can see exactly where that is on the y-axis. So pretty straightforward. So that one was set up to solve by substitution, but it's not always that way. So let's look at another example here. This is example 2. Make sure I got the right one there. Yes, that's correct. Okay, good. Hang on. Okay, good. So this is 8.1, no, excuse me, 8.2, example 2. Incidentally, speaking of twos, what's today? Today is 2/2/22. Huh. And in a couple of weeks, it'll be 2, 22, 22. So today is 4 2s. In a couple of weeks, it'll be 5 2s.
Weird.
And that's not going to happen again, probably for, I don't know, 100 years or something. I don't know. But it won't happen for a long time. Okay. Anyway, so let's write down our system. So equation 1 right here, I have 2x plus y equals 6. Equation 2, I have 3x plus 4y equals 4. Good. And there's my original system. Okay, so I'm going to solve this by substitution. I pick substitution because the coefficient of one of the variables is +1. So what variable are we going to solve for here? Anybody?
Why?
Why? Why? Because its coefficient is +1. That's why. Okay, good. So I'm going to take equation 1, and I get y is equal to 6 minus 2x, subtracting 2x from both sides. Okay, now I can go into equation 2, and I get 3x plus 4 times 6 minus 2x is equal to 4. And notice I'm using parentheses. Here it's more important to use parentheses because I'm not just substituting a single number like I do if I check a solution. I'm substituting an expression, a variable expression that has a number and a variable in it. Okay, so now I got one equation and one unknown. I'll solve it. So I get 3x plus 24 minus 8x is equal to 4. Okay, combining like terms then and subtracting 24 from both sides, I'll have negative 5x is equal to 4 minus 24. So negative 5x. Okay, I can just solve that for x right away. So x is going to be equal to negative 20 divided by negative 5. So it's equal to +4. Okay, so I got a solution for x. Okay. And you should be able to go through and solve a linear equation just as quickly as that. Just be careful of the signs and what you do each time. You see how easy it is to make mistake. I mean, you've already caught me for a couple of mistakes tonight, even though I think I did those on purpose just to see if people were paying attention. Seriously. Okay. Now I go back to the original equation. I can solve for y. So number 1, I got y then is equal to 6 minus 2 times 4 is equal to 6 minus 8 is equal to negative 2. So then my solution is for negative 2. Put a box around it. That's my solution. Now, if I check it, I always go back here to check it. Okay, and sometimes with numbers that are this easy, you might be able to check them just quickly. Notice x is 4. So in the first one, I got 8 minus 2 is 6. Checks out. In the second one here, I got 12 minus 8 is 4. Checks out. So I was able to check both of those out just by looking at them, by inspection. Call that by inspection. Okay, let's look at one more variation of this. In example 3. There's example 3. Once again, you can see this one would be an easy one to solve graphically. Those two equations would be easy to graph, and you can see it actually intersects at one of the grid lines on the coordinate system. So I would be able to tell what the solution is. But let's look at example 3. So example 3, we have, okay, fine. Example 3. So my solution or my system is, where'd it go? Y is equal to negative 3x plus 5. And number 2 is where'd it go? Y is equal to negative 3x minus 2. Okay. So right away, you should be able to tell something about this system by inspection. What's the problem with this system?
They're parallel.
Yeah, they have the same slope. So they're parallel lines. So here, m is equal to -3. And here m is equal to -3. Now I can tell they aren't the same line because the y-axis intercept is in 2 different points. So that means they're parallel lines. But maybe you didn't recognize that. So let's see what happens when you try to solve it. So if I make the substitution, so I'll take equation, 1's already solved for, so I'll go to equation 2. So I get -3x plus 5 is equal to -3x minus 2. Okay, again, I get a single equation and 1 variable. So removing the parentheses, and I'll remove the parentheses, and I'm going to add 3x and subtract and add 2 to both sides. So let's do that. So I'll get -3x plus 3x plus 5 plus 2 is equal to -3x plus 3x minus 2 plus 2. So here the x's cancel out, the x's cancel out over here, and I get 7 equals 0. So is that correct? The 7 equals 0? No, it's not correct. So what we have is called a false statement. So that means there's no solution. So, and this will come in, be more of a, be more characteristic of when we solve systems by matrices and determinants later on. Okay, especially 3x3 systems. When we get a false statement anywhere along the line, that means it's an inconsistent system and there's no solution. So I should have written that down there, inconsistent system. Okay. Inconsistent system, no solution. Okay. Let's go back over here. So any questions on those 3? Pretty straightforward. Let me clean up this side. Okay. So that was objective A, solving a system by substitution. Good. Excellent. Excellent. Okay, good. Now we're going to look at objective B, solving a system by elimination. So elimination is just as the word implies, it means we're going to eliminate or remove one of the variables. Okay, this is also called the addition method. I'll write that up there. So in some text, or if you Google it online, you might see it referred to as the addition method. Okay, same thing. It's elimination method. Okay. Let's see. So let's write down the method then. So the first thing we're going to do is put the equations in standard form. One, put in standard form. Okay, so your first question is, what's standard form? This is standard form. AX plus BY equals C. Ah, that's not a C. That's a backward C. That's standard form. Okay, it's not slope intercept form. So remember, we sort of talked about this last time. I did mention it. So in linear equations, there's two forms: slope intercept form and standard form. So this is the standard form right here. Okay, then what's two? Okay. Okay, so two is, we're going to multiply. I'm going to abbreviate because I'm running out of room. Multiply by whatever makes one variable term opposites. Okay, so what does that mean? That means if I have 2x, then the opposite of that is minus 2x. Okay, so the coefficient, whatever's in front, is the opposite sign. Okay. Then 3, we can add the equations. Then when I add the equations on step 3, because one of the terms are opposites, that term will go away. It will be eliminated. All right. Then 4, solve for one variable. Okay. And then 5, I can go back and substitute to solve for the other variable. Hang on. Okay, and finally 6 right here is to check. Okay, we're going to go over this here in a second. Let me outline it here. So this is our method to solve by elimination. Okay. Okay, so 1, we're going to put in standard form. That's AX plus BY equals C. 2, multiply by whatever makes one of the variables into opposites. Okay, so that means they have their coefficients have the opposite signs. And once I do that, 3, I can add them together, and that will eliminate that variable. And then that will leave me with one equation and one variable, so I can solve for one of the variables. And then 5, substitute into the original system to solve for the other variable. Okay, just like that. And then finally 6, check. Okay. Okay, let's look at some examples on this one. Let's see. What do we got here? Example. Now I am over on page 512 on example 4. Okay. Okay. Turned around here. There we go. So here's example 4. Number 1 is 2x minus 3y equals 0. And number 2 is negative 4x plus 3y equals 1. There's my original system. So notice in this system right here, let me make sure I wrote that correctly. Did I write that correctly? Yeah, I did write it correctly. Okay, notice on this equation, in this system here, basically it's already done for me. Notice the opposites, the y's are opposites. So all I have to do is add the two together. So here I'm just going to add 1 plus 2, and I'll get negative 2x equals 1. So x is equal to minus 1/2. Okay. And then I just go back into any of the original equations and solve for y. So in this equation, which one would you go back to solve for y? Which one do you think? Number 1. I would do number 1 also. And why is that?
Because it's just negative 3y. There's no other. It wouldn't be like
Well,
negative
because
4.
there's a 0 over there.
Oh, okay, yeah.
Yeah, that's why I would do it, because there's a 0 on the other side. So let's do that. So let's go back to equation 1 right
Isn't
here.
that positive 1/2?
Well, here I got minus 2x. Notice I added the two equations right here. So I got negative 4 plus 2 is minus 2x. And here I got 0 plus 1 is 1.
Yeah, but I thought it was 0.
It was
It's negative 1.
Is it negative? Hang
Yeah.
on. Maybe I wrote it down wrong. Let me see. Let me double check. I got positive 1 here. Wait a minute. Let me look in the book. Sometimes I miswrite my notes. Oh, it is negative 1. Bonehead. Okay, so this is negative 1 over here. Negative 1. That means this will be negative 1. So this will be a positive 1/2. Okay, good.
That makes sense.
Thank you very much. Okay, good. But now I'm still going to go back into that first one right there. So I'll get 2 times 1/2, which is real nice, minus 3y is equal to 0. So 2's will cancel out right there. And I get negative 3y is equal to negative 1. So y is equal to 1/3. So here my solution point is 1/2, 1/3. Again, those two would be easy to graph, but you can see there the solution lies between grid lines, which means I would have to estimate the final answer. No problem. Let's work another one. This time I'll double check my notes right here, make sure I got the right problem. But obviously, having two terms as opposites from the start is not always the case, as we will see. Okay. All right. So this is example 5. Now we're over at the top of page 513. Let me see. Is that right? Did I write that right? 5x plus 4y equals 22. Negative 3x plus 8y is equal to positive 18. Okay, good. Got it written down. Okay, so here's example 5. So in this system, I have 5x plus 4y is equal to 22. And number 2, I have, I'm running out of ink here too. I'm running out of ink here. I have negative 4, no, wrong. Minus 3x plus 8y is equal to 18. There's my original system. Running out of ink there too. Ink a dink out of both of them. Okay, we'll finish that one up in blue. Dang. Blue's almost out also, but it's just about time for a break. In fact, let's do that. Let's take 10. That way I can replenish my pens and then we will come back. So it's now 8:15. Perfect. So we'll come back at 8:25. The math train will leave the math station. All right. Okay. Don't go too far. Take a break. Okay. Pens here. And okay. Hmm. Okay, any other questions during the break here?
No, sir. All's good.
Okay. Hmm.
I have a quick question. It's not really related to the subject.
Okay.
It's I don't know if anybody knows, but are there like restrooms open on campus also? So if
Yes.
you're like, oh, okay, all right, thank you.
Mhm. Yeah. Oh, yeah. They have nice restrooms. Have you been to the Mesa campus?
Yeah, I use the Wi-Fi.
Okay. No, it's a nice camp, and the math and science building is really nice. So it's only a couple of years old. And it's very, I guess, modern. It looks like a university and not a community college.
Yeah, when I first got there a couple of days ago, I think it was Monday morning. I drove over there. I was like, this don't look like community college. It looks like a university.
Yeah, it does. Yeah, and they're building new buildings too.
Yeah.
I mean, the construction has been going on for a number of years.
The one thing I don't like is just the the stairs by the lot when you park in parking lot 1 and you have
Oh,
to go
yeah,
up the
yeah.
stairs.
Uh-huh.
And I was like, oh
I
my
know
goodness.
those are a lot of stairs. There's people that run up and down those stairs too. I have bad knees, so I can't use the stairs, so I got to use the elevator. But the student services building is really cool. Did you go in there and see the elevator and it's like a central atrium. So you go up in a glass elevator and you can see, well, it's not all glass, but it has windows in it. So you can see down into the atrium what everybody's doing. It's pretty cool.
It's closed for right now because when I went there Monday, there's no one there, but
Yeah.
like counselors, but they just couldn't let anyone in the offices. But there were students on top of the stairs guiding where all the students should go. For
Oh,
like,
okay.
because there's some in class right now, but it was
Yeah,
just
there's
very
supposed to
minimal.
be some classes on campus, yes, but
Yeah.
none of the math classes. Well, I'll take that back. I think no, none of the math classes are on campus this week.
Nope.
But a couple of the advanced math classes are on campus next week, and then they'll all be on campus on week 4.
Can't wait for that.
Yeah,
need to be in
I
person
can't
'cause-
either. I've had enough of this. This is my 4th semester doing the virtual one here, so I've
Oh.
definitely had enough of that.
Who decided what classes were required to be on campus and what could survive off campus?
You got me. I don't know. But whoever it was, I don't like the solution. I was ready to go back. I did all on campus last semester. So I was one of the few ones that went back on campus. So most people were staying off campus, but I said, I'm going to go back on. And they said, okay, that's fine. I can. And so I did my classes, 2 classes just like this, all on campus last semester. But now this semester, then they divided it up like this. So it's everything is split up and fractured. Who made the decision? I don't know. It wasn't me. That's for sure. Whoops. Bella. Come here, puppy. Bella, come here. Come here. Come on. Come up here. Come here. They want to see you. Come on.
It's your dog.
All the way up. Yep.
Bella.
Yep. Here we go. There we go. Here's my dog. That's Bella. Hello.
It's a cute
Wanna learn
dog.
some math? Yeah. All right.
What breed is she?
She's a Cocker Spaniel.
Ah,
Let's see. Before we get started, I got to refresh my water here. Hang on. Be right back. go to class? Yeah, I did. They had the little Hershey's Kisses, the kisses. Okay, I'm back. All right. Oh, looks like it's time to start. Hang on just one second here. Come on, let's open up. There we go. Gotta have some chocolate. Okay, so we're back. Pens are refreshed. There we go. Yay. So let's take a look at this. So here you have two options. So one of the things to look for, if one of the variables isn't opposites or one isn't already solved for, then either look at variables that are multiples of one another. So notice 4 and 8. 8 is a multiple of 4. Okay, and that will make it easier to work with, or look for variables that have opposite signs. So here 5 and 3 have opposite signs. So that would be a choice. Now, what I'm going to do is pick these ones right here, because I only have to multiply one equation. Over here, I would have to multiply this equation by 5 and this equation by 3. So I have to multiply 2 equations. Okay, so I want to keep it as simple as possible. And so what I'm going to do is multiply this equation by -2. Okay, so one of the things in solving these, we always try and do multiplication and addition. We never do division or subtraction. Always try to do multiplication and division. Addition and subtraction are harder things mathematically. I mean, you go, well, duh, they're not that hard. Yeah, but they are a little bit harder mathematically, and it's easier to make mistakes, especially sign errors. And another thing is always say what you're doing. So here's what I'm going to do. I'm going to go -2 times equation 1, -2 times equation 1 up there. So that'll give me -10x minus 8y is equal to -44. And remember, you got to multiply all of the numbers in there on both sides of the equal sign by the same number. That's why I write it down over here. This, in addition to numbering the equations and putting a line under it, another good habit to get into is say what you do each time. Write it up there. That way, if you go back to check your work, so some reason the solution doesn't check, you can't get anything. So you try and go back and see the steps that you did in order to get there. If you say what you did each time, then that makes it a little easier. So now I'm just going to write down equation 2 again. Notice I'm not just going to add these two right here. I'm going to write it down again. -3x plus 8y is equal to 18. And I'm going to put a line under it. So notice these are two. That's the original system. This is the second system. Every time I multiply by some number, I actually change the system a little bit. It's still the same system, but I just write it in terms of different numbers. Okay. So now down here, I'm going to add 1 plus 2. So I add these two together. I get -13x. Not liking that. I'm not liking 13. But here my y's cancel out. So that's good. And then this is equal to negative. So what's the difference between 44 and 18? It looks like it's 26. Oh, that's nice. Notice I can check it right here. 6 and 8 is 14. I carry the 1. 2 and 1 is 3 and 1 is 4. So it checks. Okay. And now I got one equation and one variable. So x is equal to -26 divided by -13. So x is equal to +2, which is nice. Okay. And now I'll just go and pick any one of these, whatever easiest one looks like the easiest one to solve for y. And I would pick number 1 right here because its coefficient is only 4. Okay, so let's pick that one. So I'll pick equation 1 right here. And I get 5 times 2 plus 4y is equal to 22, or 4y is equal to 22 minus 10. 4y is equal to 12. Y is equal to 3. So that's real nice. So I got a nice solution for this one. So we got a solution of, what was X, 2 and 3. Okay. So you can see once again, that's not as easy to graph as my other ones, but I could solve that graphically. And the intersection would be on some grid lines. Okay, but it's not as easy to graph as some of our other systems. Okay, let's look at another one right here. This is example 6. Okay, so we saw what happens when you get an inconsistent system. We saw that before when we looked at the substitution method. But example 6 is an example of a dependent system. So let's see what happens when you get a dependent system. So we don't know that it's a dependent system. Okay, so let's look at example 6. Let's write down our system right here. So I got 2x plus 3y is equal to 17. And then for 2, I have 5x plus 7y is equal to 29. And there's my original system. Okay. So, you know, it looks fairly innocuous, like it could have a solution. So I want to pick, let me switch around here. Stand by. You can always tell looking at, I can see myself over here. So when my head, my big fat head is blocking that side of the board, I know it's time to switch around. Okay. So here I'm going to pick whatever looks like the easiest variable to solve for. And here I would pick X. The reason being is 2 and 5 are easier to multiply by than 3 and 7. Okay. Basic multiplication table facts. 2 is an easy number to multiply by, and so is 5. So that's what I would do on this one right here. So what I'm going to do is multiply the top equation by -5 times equation 1. And again, I'm saying what I'm doing right there. And then I'm going to multiply equation 2 by just 2. 2 times equation 2, just like that. Again, I'm saying what I'm doing. Okay. So here I'm going to get -5 times 2x is -10x. -5 times plus a 3y is -15y is equal to -5 times 17 is 50 plus 35 or 85, -85. But you better check me on that one. So notice I went 5 times 10 is 50, 5 times 7 is 35, 50 plus 35 is 85. Okay. Now the second one, I'm just doubling that. So I get 10x plus 14y is equal to 58. Okay. And there I've reorganized the system there in terms of different numbers. So now I'm going to add them together. 1 plus 2. So here the x's cancel out. Over here, I get -y is equal to, yep, that's right. And over here, I get negative, let's see, I thought this was supposed to be a dependent system. That's okay. Let's see what happens. And the difference between 58 and 85 is 27. Is that right? 27. Let's see. 7 plus 8 is 15. Carry the 1. There's 7 and 1 is 8. Okay, that's good. So here y is equal to 27. Oh, darn. I thought this was going to be a dependent system. Let's see. Okay, no sweat. So then I'll go back and just pick equation 1 in my original system, and I'll solve that one for x. And the reason I picked equation 1 is because the x coefficient is 2, and 2 is an easy number to work with. So here I got 2x plus 3 times 27 is equal to 17. Okay, so 2x is equal to 17 minus 81. I think that's right. So there's 60 plus 21 is 81. Yes. So we get x is equal to minus, what's the difference between 17 and 81? So think about that. When you think about the difference, think about what do I have to add to the smaller number to get the larger number? So what do I have to add to 17 to get 81? Okay, well, 7, I need a 4 for that, right? And that will get me 11. And then I need a 6 right here. So it should be negative 61 divided by 2. No, negative 64. Yeah, negative 64. Let's see if that's correct. 7 and 4 is 11. I carry the 1. 1 and 6 is 7 and 1 is 8. Okay. So x is equal to negative 32. So here my solution was negative 32 and 27. So you can see again, that would be easy to graph. And here the intersection is on grid lines, but the numbers are really large. So I wouldn't want to solve that one graphically. Okay. I thought that was going to be a dependent system, but it wasn't. So let's see. Maybe example 7 is, let's see. There's my solution on that one. Any questions on those two examples, solving by elimination?
Nope. We're
Okay,
good.
good. Then let's look at example 7 here. Boom. So now over at the top of page 514. Okay. Let me clean this up. Okay, go. Okay, so let me write down our system. So here we got 3y minus 2x is equal to 6. And 2, we have negative 12y plus 8x is equal to negative 24. Now, you might see something on this one by inspection right away. Anybody notice anything by inspection right away without even looking at the book?
They're all multiples of each other, pretty much.
Yeah, they're all multiples of 4. Actually, if I, multiples
You
of
can
4. So
reduce-
if I multiply that one by 4, I'll get that one in every case. Okay, which means they're the same line, but maybe you don't recognize that. So let's use our method of elimination to solve this and see what we get. Okay, so I go, oh, nice. So I'm going to multiply equation 1 by 4. So I do that, I'll get 12y minus 8x is equal to 24. Then I'll bring down equation 2. Negative 12y plus 8x is equal to minus 24. Now I'll add the two together. And I get boom, 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 0 equals 0. Okay. And the question was, does 0 equal 0? Yeah, it does. So this is a true statement. Which means what? It's a true statement. That means it's a dependent system. So that means there's infinite solutions. So how do we write this solution? So here we got to write the solution in what's called set builder notation. So I go x, y is equal to the set of all x, y such that, and then copy one of those. 3y minus 2x equals 6. And close the set. So there's the solution in set builder notation. So it says xy, any xy will be a solution if the set of xy such that, that's what that long straight line means, such that one of the equations up there, 3y minus 2x is equal to 6. That means anything that satisfies this equation will satisfy that one, and any other equation that I write that's a multiple of those two. Okay, so this is called set builder notation. Set builder notation. Okay, and you might see that in the book for some of the solutions. And so that's what the author is saying there. Okay, good. Let's see. Good. So let's work one more. And this is where we have a mixture of fractions and decimals. Okay, so we're going to solve a sort of a mixture problem by number types. I mean, it's not a word problem or anything like that. It's just solving a system, but it's a system there where one equation is written in decimals and the other one is written in fractions. And let's see what we can do about that. Okay, so this is example 8. Let's see. Okay, so we got 0.2x plus 0.3y is equal to 1.7. And then for 2, I have 1/7 x plus 1/5 y is equal to 29 over 35. 29/35. There's my system. And you're going, whoa, that doesn't look real nice. So what we have to do here is eliminate the decimals and fractions. So remove decimals and fractions. That's what we got to do. Okay, so remove the decimals, you have to multiply by a power of 10. And that's a 1 with the number of zeros equal to the most number of decimal places. So here there's only one decimal place. So that means I'm going to multiply equation 1 by 10. 10 times equation 1. So when I do that, all of the decimal points will move over to the right one place. So then this will become 2x plus 3y equals 17. And for the next one, I multiply equation 2 by the LCD. Okay. So equation 1 here, I multiply by power of 10. Okay. So equation 2, I have to multiply by the LCD. So what's the lowest common denominator for equation 2?
35.
35. Yeah, it's going to be the largest number that will eliminate all of the denominators. So in this case, it's 35. And both 5 and 7 are multiples of 35. So I'm going to multiply this one by 35. So 7 goes into 35 5 times. So I'll have 5x. 5 goes into 35 7 times plus 7y is equal to 29. Okay, so there I've rewritten it without the fractions and decimals, and we solved this one before. So this is the same as which one? Hang on a minute. Boom, 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 boom. There it is right there. So this is the same as example 6. There you go. Same as example 6. Okay, but the whole point of that is to remove the fractions and decimals. I always, just a hint here for tests, I always like to throw one of these in, maybe for the extra credit. Okay. It won't be as difficult when you rearrange it to solve as this one, but to see what people will do to eliminate the fractions and decimals. Okay, let's see. All right.
Mr. L, if we have a problem on the exam where it's infinite solutions, do we have to write it out in set builder notation?
Well, I might ask you to write out what the solution is. Yes, and then you would have to write it in set builder notation. Yeah, but that's easy. You just use that set notation like I put on the example right there. And I think it's in the book also. Let's see. Let me double check that. Yeah, it is. So it's in example 7 at the top of page 514, and the author has the answer in set builder notation.
Okay, thank you.
Sure. And it might even be that way for a couple of the homework problems. I'm not sure. I can't remember. Okay. So now we're going to move on here. I know you want to go to school too. Okay. My dog wants to go to school. I think she's really lonely. There's nobody here to play with her. So she's bugging me. Hello. Okay. So now we're going to go over to 8.3, where we're going to look at some word problems that result in a system of equations that then we can solve. We've already seen these in 8.1, but there we were just developing the systems. But now we're actually going to develop them and solve them. Okay, so let's take a look at that. In fact, our first one is our jewelry design problem. Oh, that's nice. Okay, good. That's actually the second one. Excuse me, my bad. The first one is our endangered species problem, but that was even easier. So let's go ahead and set these up and then we'll solve them. Okay, so now we're in section 8.3. All righty. Let me go over here. So 8.3 is called solving word problems, where solving systems of, hang on. I don't like the way the author worded it there. Wait a minute. Look at my notes. Okay. Let's see. So we're looking at solving two variable system word problems. 8.3, solve two variable system word problem. There we go. So we're going to solve two variable system word problems. So word problems that are going to result in some sort of system in two variables that we have to solve. Okay, so let's look at example 1. Okay. So example 1 is our example where we're just using keywords. So we're using keywords that will render an sentence that I can change, then translate directly into an equation. Okay. So let's read it. So it's a word problem. So remember our word problem method. The first thing I have to do is read it. So it says, in 2016, there were 96 species of birds in the United States that were considered threatened or endangered. Okay, fine. The number considered threatened was one more than 1/4 the number considered endangered. How many U.S. bird species were considered endangered or threatened in 2016? So the trick here is if you can say it again in your own words that make easy sentences. So cutting out all of the other baloney words that you don't need. Who needs 2016? I don't care. So just thinking about this, I have endangered and threatened and endangered. Okay, so the first thing I can see is 1 right here. Threatened plus endangered is 96. Okay, so that's going to give me an equation. T plus E equals 96. So there's one of my equations right away. Okay. Now, number 2. 2 is a little bit harder. So 2 says, threatened was one more than 1/4 endangered. Threatened was one more than 1/4 of endangered. Okay. What does that mean? Let me back up here and do this on this one. I'm going to do that in a different color. So number 1 here said T plus E equals 96. Number 2 then says T was is my keyword. This here is my equal sign word. This is my equal sign word right here. So when you do this translation, everything revolves around the equal sign word. You want to find the equal sign word in the sentence, and then that's everything on the left of the equal sign will be on the left, everything on the left of the word will be on the left of the equal sign. Everything on the right of the word will be on the right of the equal sign. The other thing here is the word of, right here, of. So of means multiplication when you're talking about fractions or decimals or percents. Of means multiplication. So here we got t equals 1/4 e plus 1. Okay, so let's rewrite the system up on the top right here. So number 1, I have t plus e equals 96. And number 2, I have t is equal to 1/4 e plus 1. I put a line under it. There's my original system. Now I got to think, how do I want to solve this? So do I want to solve it by graphing? Nah, I don't think so. Do I want to solve it by elimination? I don't think so. How about substitution? Notice one of the variables is already solved for. So here, substitution is the ticket. There we go. Solve it by substitution. So notice t is already solved for. So I'm going to substitute that into equation 1 right here. So I'll have parenthesis 1/4 e plus 1, close parenthesis, plus e equals 96. Okay. Now, unfortunately, I got fractions, but that's okay. I can deal with the fractions. So let's remove the parentheses and combine and move like terms together. So I'll get 1/4 e plus e plus 1 is equal to 96. So 1/4 plus 1 is what? 1 and 1/4. Okay. But 1 is 4/4. So that's going to be 5/4 e is equal to 96 minus 1. Okay. So here's where I have a fraction as the coefficient. So when that's the case, what's the technique to solve the equation? Multiply both sides by the what?
By the 5/4 or the fifth.
Okay, we multiply by the reciprocal. We flip it over. Okay,
Okay.
so we're going to multiply by the reciprocal. It's called the reciprocal. Okay, so that means I'm going to go 4/5 times 5/4 e is equal to 4/5 times 95. You see, that's nice because 5 goes into 95. Okay, so here that all cancels out, and we got e is equal to, let's see, 5 goes into there. What? Man, higher math. 19 times, I think. Is that right? Boom, boom, 19. Let's see, 5 into 9 is 1, and there's 4 left over. 5 into 45 is 9. Okay, 19. So E then is equal to 40 plus 36, which is 76 species. Okay, so notice when I write it down, I took the units on. This is called the units right here. It's what it means. What does that 76 mean? 76 what? 76 trees, 76 stones, 76 Cadillacs. What are you talking about? We're talking about 76 species of birds. Okay, fine. So there's one of my solutions right there. So where do I go back to solve for t? Right there. Okay, so I just take equation 2. So T is equal to 1/4 times 76 plus 1. So T is equal to 1/4 of 76. Let's see, that's 4 goes into there. 1, 4, 8, 3, 36, 19.
19.
19 plus 1. So T is equal to 20 species. And there's the second part of my solution right there. To check it, 20 plus 76 is 96. Okay, so it checks. Okay, any questions on that one? Again, we set it up again using keywords on this one, setting up with keywords. And the keywords are just translating into sentences right there. And I can translate the sentence into, boom, an equation. 1 for 1. Left side equals right side. Here, the left side equals the right side. Right here, left side equals the right side. Okay. Any questions on that one?
I do have a question.
Yes, you got a question. Go ahead.
Yes, I just turned 1/4 E plus E into 1.25, so I wouldn't have to do what you did, and I was able to get to 76 a lot easier. If that makes sense.
You turn 1/4 into 0.25.
Yeah, so 1/4, so 1/4 E plus 1, where we were at that point. When I added them together, instead of putting it as 5/4, I just put it as 1.25.
Okay, so you changed it
okay?
into decimals. That's fine.
Okay.
Okay. If you want to do that, that's fine. I'll tend to keep it as a fraction.
Okay.
A lot of people will change, and where people run into problems with this is when they get into things like thirds. A third, they'll put in 0.3 or 0.33, and then they end up with the wrong answer because you need to keep it as a fraction if you're working with like thirds, sevenths, anything that doesn't make it a nice rounded off decimal. Like
Okay.
halves, that's 0.5. Quarters, that's 0.25. Fifths is 0.20. So any of those 2, 4, 5 will always round to a nice truncated decimal, which makes it easy to work with. But if you're working with thirds, sixes, sevenths, ninths, those will all be not nicely truncated decimals.
Gotcha.
Okay. Anyway, some food for thought. If you want to change it to decimals, that's fine. You can do that. Okay. Let's look at one where we use a table. So this is example 2, which we set up before last time, and we also saw it again in the review. We'll set it up again here. So this is example 2. Oh, keep this, yeah. Okay, so example 2 here, we're going to solve with a table. Okay, so again, it's a word problem. Let's read the word problem. So it says, example 2. This is the jewelry design. So in order to make a necklace, Starbright Jewelry Designer, Starbright Jewelry Design purchased 80 beads for a total of $39. Some of the beads were sterling silver beads, costing 40 cents each, and the rest were gemstones costing 65 cents each. How many of each type were bought? Okay, so I look at this And this is, I recognize this as my, the relationship here is buying things, the cost relationship. So I recognize that. In other words, the cost is equal to the amount that you buy times the price. So that's the relationship. Now, amount, unfortunately, is a word that has more than one meaning. But here it has a meaning of, it could be related to money. What's the amount that you paid for that, for example? Or it can be how many of an item, and that's what we're talking about here. So the cost that you pay up at the cash register is equal to the number of loaves of bread that you buy, the amount of loaves of bread, times the price per loaf. That's what we're talking about there. Okay, so I'm going to set this up using a table. So over on the left-hand side, I have my items. And number one, I got silver. And number two, I got gem. And then down at the bottom, I always have total. And then across the top is my relationship in backwards. I'm going to abbreviate amount times the price equals cost. Okay. Now I've made my table. So my items are over here. I put my relationship in backwards. And we're going to see there's more than one kind of relationship. I'm going to have like about 5 different types of relationships that I could always have. I can have one for interest and percents, and I can have one for time and distance, for speed. So there's different types of relationships that I can have. But whatever it's equal to always goes over here on the right-hand side. Okay, the author doesn't set them up like that in the book. In fact, the author sets this one up in 8.1, so he doesn't set it up again in 8.2. So now I just fill in all the information that I know. So I need to find the amount, the number of silver and gemstone beads. So that's going to be my 2 variables, S, G, and there's a total of 80 of them. So I just fill those into my table right there. The price, once again, here's our dollars and cents sort of thing. So I'm going to put in 40, 65, and 3,900 down here. Nothing right there. Okay. Then for this one over here, I just follow everything right across. My relationship. So this times this is equal to this. So I have 40S. And this times this is equal to 65G. There we go. Okay. Now, my two equations fall right out of here. So here, this plus this is equal to that. So there's one equation right there. This plus this is equal to that. There's a second equation right there. So here's my system. Then I'll put it down here at the bottom. 1S plus G is equal to 80. And 2, 40S plus 65G is equal to 3,900. Okay. Now I just want to find, how am I going to solve that one? Okay. So once again, notice the coefficients of these two up here are +1. So the easiest way to solve this one is by substitution. All right. So what we'll do is, let me write it up here again and we'll solve it down this side over here. Let me move over here. So I got 1 S plus G is equal to 80 and 2 40S plus 65G is equal to 3,900. There we go, right there. So I'm going to use substitution again. And why am I doing that? Because of the coefficients of both of the S and the G is +1. So that's just the easiest route to solving this. So let's solve for G in terms of S. So number 1 right here. Wait a minute. Yeah. Number 1, I got G is equal to 80 minus S. No, let me do the other one. I don't like S as a variable because it looks like 5. And it looks like 5. And if some people get really sloppy, it can even look like 2, but definitely 5. So I'm going to go the other way. So I got S is equal to 80 minus G. Hang on. There we go. 80 minus G. Okay, then I'll take equation 2, and I got 40 times 80 minus G plus 65G is equal to 3,900. Okay, so I just reorganize my system right there. And I got one equation and one variable. So let me remove the parentheses. So 40 times 80. Here, you don't have to use your calculator. All you do is multiply the 4 times the 8. That's basic multiplication table facts. 4 times 8 is 32. And you add 2 zeros to it. So here I got 3,200 minus 40G plus 65G is equal to 3,900. Okay, good. So now I'm going to subtract 3,200 from both sides and take the difference between 40 and 65. So the difference between 40 and 65 is 25. So I get, hang on just a minute. Let me move over this way a little bit. So 25G is equal to 3,900 minus 3,200, or G is equal to, what is that, 700 divided by 25. And you can even do this without the calculator. 25 is like a quarter. So how many quarters are in $7? How many quarters are in $7? 7 times 4, right? There's 28. So here, G is equal to 28 gems. Okay. And then what am I going to use? Right at the top there, number 1. S is equal to 80 minus 28. I substitute back. So S is equal to, what is that? 52 beads. And I just add these two together. So 52 plus 28 is 80, and checks out. Okay. All right. So one thing about the table method. So the table method is a way to organize your information and get the equations at the same time. So a lot of people just take a problem like this and just start slinging numbers around, making, like bogus equations. I don't know where they get that information. As long as they get 2 equations, they're happy and they'll get 2 answers. Even if one of them is negative, that's okay. They got a solution. So the table method helps you organize your information. Okay. Whoops. Whoops. That's my desk lamp falling to the floor. Hopefully it didn't break. Okay. So now we're going to go over to example 4. So, nope, excuse me. Example 3. So example 3 is another different relationship, like this relationship, the buying things relationship. So example 3 is like that, but it's a mixture. So hang on just a minute. It's called a value mixture problem. But, oh, I forgot to do one. Even before I do one of those, I'm going to do what's called a number problem. Let me go back over here. So any questions on these two that we did? Okay, pretty straightforward. This is actually what we call a number problem here, where we just use the keywords to solve for something. But I'm going to do even a simpler number problem, one that's putting on that is commonly put on a lot of entrance exams, things like that, because they know it's going to throw people. They don't understand what's going on, and they just start, mixing numbers around. All right, so I'll give you an example. So let me clean this one up here. Okay, so this is a number problem. Hang on. Oh, okay, good. All right. So this is an example, which isn't in the book. Called a number problem. Okay. And I'm going to write it down, and you'll see that we can solve this with keywords. So the first one says the sum of two numbers is 32. Okay. The sum of two numbers is 32. And then the second sentence is the first number is 3/5 of the second number. What are the numbers? Okay. So the sum of two numbers is 32. The first number is 3/5 of the second number. What are the numbers? And right away you're going, oh man, come on. And you're just trying, okay, we got 7 and 9, we got 8 and 16, we got 32 and I don't know, 5. And you're just slinging numbers and making it a guessing game. So the thing here is you solve by translation. So you translate keywords. So notice what I got is two sentences. One sentence, second sentence. And in each sentence, there's a verb word. So look right here. There's the verb word in the first sentence is, and down here, second is. Okay, those are my equal sign words. So in sentence number 1, I got the sum of two numbers is 32. What are the numbers? I don't know. X plus Y equals 32. Okay, so just use your X and Y variables. The second one, the first number, that's X, is, so X is 3/5. Again, we got the keyword of, which means multiplication. 3/5 of Y. And there's my system. Okay, so you can see that one just lends itself to substitution because X is already solved for. So in solving that one, we take equation 1 and we got 3/5 Y plus Y equals 32. Okay, remove the parentheses. 3/5 Y plus 5/5 Y is equal to 32. That's 1 Y. 1 is 5/5. So 1 is any number divided by itself. So if I know what the denominator is, I can make the other coefficient the same with that denominator. So now I got 8/5 Y is equal to 32. So 5/8 times 8/5 Y multiplying by the reciprocal is equal to 5/8 times 32. 8 goes into 32 4 times. So Y is equal to 20. So that's one of the numbers. So it's the other number. So I just take equation 1 and I get, there it is right there. X is equal to 32 minus 20. So X is equal to 12. So my two numbers are 12 and 20. Okay. So again, this is what's called a pure number problem. The endangered species was also a number problem, but it's not in this form right here. This is just numbers. Two numbers add to this. One number is a multiple of the other number. What are the two numbers? Okay. But again, you can just solve it with keywords. Okay, good. Enough of that one. Let's move on over here. Clean this up. And at least we'll have, I think we should be able to set this next one up. We might not have enough time to solve it, but we'll see. This is example. This is a value mixture problem, and it's example 3. Okay. Okay, so what this is I have two things of different values and I'm mixing them together. The bead problem was actually a value mixture problem, but that was a pretty straightforward one. Here, it's maybe not quite as straightforward. Let's read this one. So this is example 3, and it says, hang on, there it is, okay. And it's called blended teas. And it says Teapots and Treasures sells loose oolong tea for $4.30 an ounce. Donna mixes oolong tea with shaved almonds that sell for $1.10 an ounce to create Market Street oolong blend that sells for $3.50 per ounce. To make 300 ounces of Market Street oolong, how much tea and how many shaved almonds should Donna use? Okay. Yeah, right. So this basically is the same thing that we saw before. Okay, it's the cost relationship. Okay, so we'll set this one up anyway. So I got my items. And what do I have? I have tea, one item, and I have 2 items as almonds. And then down at the bottom, I have total. Always have the total at the bottom. Okay, then across the top, I got my cost relationship in backwards. So the amount, some people like to put price first, doesn't make any difference, times the price equals the cost. Okay. And there's my table. So now I'm going to fill it in. So the first thing is pick the variables. So they asked me to find how much of each. So that's going to be what I'm looking for. So I have T here for T, and I have A for almonds. Whoa, hang on. Okay, good. All right. Okay. And let's see. Now, keep in mind that these aren't numbers of things, but I'm buying these things by ounces. So it says they made 300 ounces. So where does that 300 go? It goes right here. So the amount of tea plus the amount of ounces of almonds adds up to 300. Now the price. So this is, what's the price here? Let's see, $4.30. And then the other one was $1.10. Okay. See what's in thing. And it says the blend sells for $3.50 per ounce. So that goes right here. So you can see this one is tracking out a little bit differently, but that's okay. We can still get 2 equations out of here. And you follow everything straight across like this. This times this equals this equals this equals this. Before, I didn't have something right here in the other one. So now up here I get 4.3 T and 1.1 A is equal to 300 times 350. What was that? 300 times 350. Okay. So down here in the bottom, I got, I'll add it, I'll put it in here. So I got, well, let's use the calculator. Hang on. On. Good. So I have 300 times 3.5 equals, and I get, let me do that again. 300 times 3.5 equals, okay, I got 1,050. So right here, I get 1050. Okay. So where are my equations? The same place. So here's one equation right here. Here's the other equation right here. So let's write down the system. We'll solve it next time. So here's my system. Number one, I got T plus A is equal to 300. And number two, I got 4.3T plus 1.1A is equal to 1050. There's my system. Again, we don't have time enough to solve that now, so we'll solve it next time. Okay? So any questions? I know we went pretty fast. We covered a lot of things. But we will try to resolve some more of them next time.
Thank you.
Okay, you're welcome.
Thank you for your time.
Thank you for attending. I appreciate that. Everybody, make sure you sign in again to the chat. Okay, please sign in the chat.
Have a good night, Mr. L.
You too. Thanks.
Have a good week.
Thanks, Antonio.
Yes, sir.
Have a good night.
Okay, thanks, Ryan. You too. Have a nice rest of the week and weekend, everybody.
You too. Stay safe.
All right, thanks.
Professor, when will you be posting the homework? Will it be later tonight or tomorrow?
No, hopefully I'll point it to do it tonight. It all depends. It depends on how long it takes my uploads to take to YouTube.
Okay, let me open it.
But I'll put it on a Canvas also.
Okay, I'm going to get a tutor because I've been out of school for many years. I'm 50, so this is all coming slowly. So
Okay.
is there any way that when is your office hours? Do I go into the office at this point, or I don't know how to get in touch with you?
Okay, well,
What to do.
unfortunately, normally I do office hours in the classroom. I
Right.
try to do it before class starts. I try to get there at least like 30 to 40 minutes before class starts so I can do office hours. But this time things are kind of convoluted because they did this virtual and then in the classroom
Right.
mix. So what you can do is, I haven't set up an actual office hours time yet.
Right.
I might
Right.
do that. Typically, I set it up on Friday afternoon. Again, it depends on my other work schedule.
Okay.
So I
Yeah,
have
it's just
another job that I have to work at.
I understand. Let me know. I'm definitely going to be one that needs to needs a little bit more hand holding because this is some of this
Yeah,
is
that's
coming
fine.
back.
And
Yeah.
anytime you have a question on any of the problems, you can always email me.
Okay.
Yeah,
Okay.
but if you email me, don't do it through Canvas. Do it through my Hotmail email that's at the top of the syllabus.
Right. I did do that. Okay.
Yeah.
All right. I'm going to go ahead and get a tutor just to stay above all of this before I get behind. So
Okay. Hey, thanks a
All
lot,
right.
Kendra.
thank you. You have a good evening.
Yeah, you too.
Bye-bye.
Thank you. Bye-bye.